You have to choose the right formula. Now you're just finding surface area in this one, right? So find the surface area. And you're given, for your surface, you're given the parametric form of the surface, aren't you? R of uv equals u times vi plus v squared j plus 1/2 v squared k. And you're given bounds on u and v, which is nice, because those are your limits of integration. So you just have to remember the formula. So in this one, the surface area formula, just integral ds symbolically, or 1 ds if you like, is going to be the double integral over d is the domain of r of uv. And okay, it's going to be, if you got to remember what ds is in parametric form. And it turns out that that's the magnitude of RU cross RV. And then dA on the end, right? Does that look familiar? So this is analogous to, okay, so you know how we had two types of line integrals? We had a line integral with respect to arc length and a line integral over the vector field. Well, which is kind of, the line integral of a vector field is a type of line integral with respect to arc length, but the integrand makes it such that orientation matters, so we separate it, right? Well, here, if you think of the flux integral versus a regular surface integral, the analogy is kind of holds up there, and even the formulas look similar. So if you think of the line integral with respect to arc length, the d little s is magnitude r prime of t dt, right? Here, d capital S is the magnitude of RU cross RV dA. So there's a nice kind of connection there. I don't know if you noticed that or not. I don't know if you care, but it will, if you see those connections, it will help you remember things better. Anyway, what does this formula tell you to find? Oh, okay, so that means we got to find the derivative of r with respect to u. What is that? Component-wise, v, comma, 0, comma, 0. Oh, that's not so bad. And then, yeah, I'll do it over here. Derivative of r with respect to v. So that's u, 2v, and v. Right? And then what do we have to find? Do you see how you're really, it's like how you compute operations in algebra, right? You're looking at the innermost things first. Inside the grouping symbols, which are the magnitude bars, you got to find the cross product, but before you find the cross product, you have to find the derivatives, the partials, right? So anyway, let's write out RU. So we got to find that cross product next, now that we have the partials. So let's see, I, J, K. So this is a true cross product, right? It's not the curl. And then so what's the middle components? V0, 0, the components of R, of the derivative of R with respect to U. And then U to V, V. So you just have to get used to finding this cross product fairly quickly, right? You don't have to be super fast. If you cross out the first column, what are you going to get? 0. You see a couple of zeros there, right? So you're finding that determinant for the first component of that matrix, that little submatrix, and that's got to be 0. So 0i, I do switch between IJK form and component form. It's just my way of doing it. When I compute the cross product, for whatever reason, I use IJK form. I don't know why. And then minus, oh gosh, my eraser, let me fix it. Okay. So cross out the middle column, and then we actually get a non-zero determinant from the submatrix V0, 0, U, V. What do we get? Minus is built in, so minus V squared J, and then plus what? So cross out this column, and then look at this determinant. Just 2V squared, right? So not a bad one to compute. 2V squared and then K, that's the K component, right? And then what do we do with that according to this formula? Magnitude. Okay. So magnitude RU cross RV, square root of something, right? What is that? Okay, 0 squared plus, well, you're going to square out that negative, so how about v to the 4th, and then what else? 4v to the 4th, which is what? 5v to the 4th. That simplifies, doesn't it? So it'd be root 5, right? Times v squared. That's your integrand. Everybody see that? So let me shrink things. That way we can see more. Okay. So can you set up your integral for me then? So your surface integral, well, your area integral symbolically looks like that, and then you set it up. What are you, okay, let's use dv to u just for the sake of argument. And your integrand is root 5, which you could pull out front if you want, and then times v squared separately. What does v run from? 0 to 1. And u runs from 0 to 2. So I'm going to let you compute that, but that's a pretty reasonable one to compute.